Have you ever heard of Dyson spheres? It's an idea proposed by Freeman Dyson in 1960, consisting of a megastructure composed of thousands of collectors placed in orbit around a star to capture its energy. The result of this proposed process isn't visible light, but the residual infrared heat that these collectors would necessarily emit when converting light into work. In this context, the James Webb Space Telescope, designed to look into the universe's past, may have just given us a glimpse of our own technological future. Webb observed the star TIC 147608927, 1,200 light-years away, dimming by about 3%, while its infrared thermal signature jumped by 17%. A pair of signals that stars do not naturally exhibit. While dust or a planet can explain small dips in visible light, this inverted pairing, less visible light and much more heat, sounds exactly like what megastructure hunters expect to see: waste heat generated by collectors converting starlight into work. Webb wasn't hunting for Dyson spheres. It was measuring carbon ratios in an exoplanet's atmosphere and stumbled upon this anomaly by chance. When stitching together the spectra, the team found a very narrow peak at 12 micrometers, precisely where billions of heated solar collectors would dump their heat. No known natural phenomenon produces such a narrow and bright peak in this band. The scientists checked all the obvious explanations: background galaxies, debris from planetary collisions. Nothing matched. The only model that fits the data is a partial swarm of kilometer-sized satellites orbiting at approximately 0.8 AU from the star. Astronomy had already detected faint hints in 2015 with the Spitzer telescope. However, its warmer mirror prevented it from distinguishing the fine details now obtained. The James Webb, however, cooled to about 40 K and equipped with a 6.5-meter mirror, is able to reduce photon noise to the point where these thermal whispers become audible. If a civilization were converting something like 1/7 of the starlight into work, Webb would finally have the sensitivity to perceive the residual heat. A true game-changer for observational astrobiology. It's important to understand that scientists have so far been unable to find natural explanations for the data. Dust around a star would re-emit heat broadly, not concentrated in a narrow peak. A planetary collision would leave clear silicate signatures in the far infrared, signals that did not appear. An alignment with a background object is also highly unlikely, and high-resolution images show nothing behind the star. Furthermore, any lightweight structure at 0.8 AU would suffer strong radiation pressure and tend to be pushed outward, unless there is active orbital maintenance, that is, autonomous systems constantly repositioning the potential energy collectors. In short, if it's technology, it requires advanced engineering and continuous maintenance. Now, what comes next is crucial. Radio arrays will scan the 4 to 8 GHz band for technological signals. Optical interferometry will search for reflections consistent with panels. And most critically, the James Webb Telescope will reobserve the same star in February. If the infrared excess grows while the optical dimming deepens or becomes asymmetrical, the megastructure hypothesis will shift from plausible to highly probable. If the excess vanishes, a transient dust cloud will likely be the explanation for the event. Meanwhile, surveys like the Hephaestus project have already pointed out other M dwarfs with 12 micrometer peaks, suggesting that similar phenomena may not be unique. If such construction is a physical consequence of energetic growth, several mature civilizations could follow the same path. The theory behind Dyson spheres has never been proven, but today we have evidence that might suggest their existence. Something immense, hot, and possibly ordered may be orbiting the star TIC 147608927, and for the first time, our instruments are sharp enough to notice. Further analysis will bring more clarity to the data. If you want to follow the upcoming spectra and raw data as soon as they arrive, subscribe to the channel and hit the notification bell. Are we on the brink of the greatest discovery in history? Let me know what you think about this in the comments.